Hello children, today we will discuss first law of thermodynamics. So the first law of thermodynamics is same as law of conservation of energy. We all know that all the process occurring in the universe involve the conversion of energy from one form to another. We can neither produce nor destroy energy by any means. So simply we can change energy from one form to another. For example, an electric generator in true sense does not generate electrical energy. It simply converts the mechanical energy obtained by the combustion of fuel into electrical energy. Okay students, so the first law of thermodynamics can be defined in number of ways. So few ways are given here in your book, and according to the first definition, energy can neither be created nor be destroyed, but one form of energy can be converted into another form of energy. As I given an example already to you, electrical generator. Then second definition, the total energy of the universe is constant. Means energy of universe is not changing, but one form of energy can be converted into another form of energy. Okay, so form of energy can be changed, but the whole amount of energy of the universe is constant. According to third definition, the sum of all forms of energy of an isolated system always remains constant. Isolated system which is not having in any relation with its surrounding. So such systems are known as isolated system, and the all forms of energy of an isolated system will always remain constant. Okay students, we can give one more definition also. On the basis of system, for a system in contact with its surroundings, the sum of the energies of the system and the surroundings at a particular moment remains constant. However, differently it is shared between the two. Okay students, so these are the few definitions of first law of thermodynamics. Now we can justify this law with the help of a few points. According to the first law of thermodynamics, it is formulated on the basis of our day-to-day experiences and has no theoretical proof behind it. The law is universally valid and has not failed even in a single case, and this strongly supports the validity of the law. Okay, as you can see that we cannot construct a perpetual machine. A perpetual machine means machine which would produce work without consuming energy. So such type of machines are not possible in today's modern science world. Okay students, so after giving or after consuming amount of energy, a machine can work only. Okay, James Joule observed that there is a definite relationship between heat energy and work energy. Okay, so these are the few points on the basis of we can justify the first law of thermodynamics. Now, mathematical expression of first law of thermodynamics. So if there is a system with internal energy as U1, if the system is supplied Q amount of heat, the energy of the system become U1 plus Q. Now if W amount of work is done on the system, so amount of energy which is supplied is Q, and amount of work which is done on the system is W. So Q energy supplied, so energy will be added with internal energy of the system, and work is also done on the system. So amount of work will also added with this. So total energy after this Q amount of energy given and work W is done on the system. So total energy will becomes as internal energy becomes as U2. So U2 will be equals to U1 plus Q plus W, or you can say that U2 minus U1 will be equals to Q plus W. So U2 minus U1 we can take as delta U, means change in internal energy. So change in internal energy of the system will be equals to Q plus W, means energy supplied to the system and the amount of work done on the system. Okay, so overall change of energy, internal energy, will be equals to Q plus W. Okay, students. So this relationship between internal energy, heat and work and is a mathematical statement for the first law of thermodynamics. It is important to note that Q and W are not state functions, but their addition, which is known as delta U, is a state function. Okay, so delta U is depends only on the initial and final state of the system, whereas Q and W are depend upon path of the change or path of the functions. Okay, students. Now, very important statement. So, work done by the system is equal to the heat absorbed by the system. Okay, and you can draw this statement from here. If the internal energy of the system is constant, in that condition delta U will be equals to 0, means change in internal energy will be equals to 0, and in that condition Q will be equals to minus W. So Q is the amount of heat absorbed by the system and minus W. This minus sign is indicating that the work is done by the system. Okay, students. So in this condition, when change in internal energy of the system equals to 0, in that condition, the heat supplied to the system will be equals to the work which is done by the system. Okay, students. So this was the first law of thermodynamics. On this basis, there are number of numericals are there on the mathematical expression of the first law. So you have to solve first these examples which are based on the first law of thermodynamics, and then you will do related questions which are given here. Okay, and share your problems. Thank you.